Joseph John Thomson, or as he is known today, J.J. Thomson, was born in Cheetham Hill, a suburb of Manchester, England. He was born on December 18, 1856. In 1870, at the incredibly young age of 14, J.J. enrolled at Owens College in Manchester. 6 years later, he entered Trinity College of Cambridge as a minor scholar. 4 years after that, he was elected as a Fellow of Trinity. He stayed with Trinity for the remainder of his academic career and was elected a lecturer in 1883 and a master in 1918. Throughout his career as an academic, Thomson won many prizes for his work in the sciences. These awards include an Adams Prize, a Royal Medal, a Hughes Medal, the 1906 Nobel Prize for Physics, an Elliott Crescent Medal, a Copley Medal, and a Franklin Medal.
Damn!
However, J.J. Thomson's most far-reaching and important legacy will be his discovery of the electron in 1897.
Thomson discovered the electron using a cathode ray experiment. From this experiment, he learned that electrons are negatively charged subatomic particles. He performed involved passing electric current through gas at low pressure. The gas was sealed with metal electrodes at each end of the tube. Both electrodes were attached to a high-voltage power source. One electrode became positively charged and the other negatively charged. This resulted in a glowing cathode ray. Thomson then used a positive plate and a negative plate outside the tube. He did this because like charges repel and opposite charges attract. He had hypothesized that the cathode ray was a bunch of fast-moving negative particles. In the experiment, the ray bent away from the negative plate, meaning he was correct.
Right now, we are going to watch a video of J.J. Thomson's cathode ray experiment. On the left is the cathode, which is the negatively charged plate, and on the right is the anode, the positively charged plate. Between the anode and the cathode is the glass tube, which is a vacuum pump. Inside the glass tube, there is a type of gas that will show the electrons moving from the cathode to the anode. It looks like almost a circle of light. However, as you can see when he's pushing the negatively charged magnet towards the beam, it's obviously not light because light does not move. This is how J.J. proved that it was electrons moving between the cathode and the anode, because he knew that like charges repel, so by pushing a negatively charged magnet towards the cathode ray, it is obvious that it was negatively charged particles moving from the cathode to the anode, otherwise known as electrons.